Alright, radical expressions and rational exponents. This is a rational exponent. A rational exponent is a fraction exponent. Radical expressions are roots, square root looking. So these are radicals, these are rational exponents. So when we want radical notation is this piece. That's radical notation. You have a radical, a root. Rational exponents is this. Rational exponents means fractional exponents. Now, this you can basically ignore because most books and most of my stuff, I don't really deal with this form. But these two things are exactly the same. It's just different ways of writing it. We'll talk about it some other time or later on. Now, this little formula, I'm going to show you what it means. You can change a fractional power to a radical. Alright? What you'll notice is, do you see the base of the fraction becomes the root of the radical? And the numerator of the fraction stays inside with the a? Can you see that? The way I remember it is, isn't the base of this the root of that? Think of a tree or a flower or anything in the ground. Where are the roots? Aren't the roots on the bottom? So shouldn't the roots be on the bottom? So the roots, this is your root. So the roots are out here. The roots are on the bottom of the fraction, so the root goes on the outside because the outnumber is the root. Anyways, I'm going to simplify and rewrite this as a radical, or in radical notation. First thing, can I reduce that fraction? You should realize you can reduce the fraction to 2/3. Okay, that was simple. Now the next question is, I want to change this to being a radical. So there's going to be x right here. Where's the 3 going to go? Where's the 2 going to go? Well, like I said earlier, according to this rule right here, this 3 is the base or the root of this fraction. And the roots go out here. And the x squared, that squared goes in there with the x. We're done. That's all we do. Now, where this comes from, this right here, you could also rewrite this as the cube root of x squared. This and this are the same thing. I like the blue. I almost always use the blue. I don't usually use this orange. But according to this formula, that a could also be stuck on the outside if you put parentheses around the root. Either way works, but this is the most common. This one. I want to change this to rational exponents. First thing, let's change it to a rational exponents, and then we'll reduce it. Which of these two numbers is going to be the base of my fraction? Well, aren't the roots the base of your fraction? So the root is the base, and the other number is the numerator. Okay, can you reduce that fraction? Yes. 10 over 4 becomes 5 over 2. And you're done. These are really easy problems once you get the switch. Number 3 is where it gets a little bit more difficult. I want to simplify this. So the first thing for simplifying, you kind of use both ideas together, but you'll go see. Anyways, 36. You have to look at that number and think of what cubed, what squared, something squared or cubed gives you 36. And you hopefully realize that is 6 squared. Now, after you do that, next, you look at this and you go, what happens when you take a power to another power? Don't you multiply those two? And what you'll end up with when you multiply those two is you're going to end up with 6, and you're going to go 2 times negative 3 over 2, correct? You're going to multiply the powers, because a power to a power you multiply. And when you do that, hopefully you can see this. Hopefully you can tell when you take 2 times negative 3 over 2, do you see these canceling? Leaving you 6 to the negative third. Now, if you can't see those canceling, what's 2 times negative 3? Negative 6. Negative 6 divided by 2 is negative 3. Just realize that becomes negative 3. Now, we're not completely done. Negative 3, we're not allowed negative powers. So this is actually 6 to the negative third is 1 over 6 to the third. Okay. So negative powers aren't allowed. And 6 to the third is 216. That's your answer. That is simplified. So basically, with these kind of problems, you look at this, you think of what squared or cubed gave me that. You multiply the powers. You then, if it's negative, you drop it to the bottom. If not, you just leave it. If that was a positive 3, your answer would be 216. All right. And then these two type of problems, you're just switching from the notation to the other notation.